What if dark matter simply winked out of existence right now? Imagine the invisible glue of the cosmos evaporating in a blink. For a second, picture the universe losing about 5 times more mass than all the stars and gas combined, because that's roughly how much dark matter outweighs ordinary matter. You'd feel nothing, hear nothing, and your phone would keep buzzing. There's no sudden flash or boom when dark matter vanishes. But over the long run, the cosmos would quietly, relentlessly rearrange itself, and that slow unspooling is where the real drama hides. First, a quick setup. Dark matter doesn't shine. It barely interacts, but its gravity shaped the cosmic scaffolding where galaxies and clusters formed. It lives in huge, roughly spherical halos around galaxies. Our Milky Way rides inside one, and that halo helps explain why stars in the outskirts move faster than they should. If you remove that halo, the gravitational balance that holds galaxies in their present shapes is altered. The invisible hand is gone. Importantly, locally, the Sun, Earth, and planets barely notice that hand. The solar system's gravity comes from the Sun, not the dark matter background. So on human timescales, nothing catastrophic happens. No earthquakes from space. No immediate orbital collapses. No instant extinction event. But stars orbit galaxies on timescales of tens to hundreds of millions of years. So the slow consequences begin to appear after a few galactic orbits. At first, outer gas and stars would drift outward as the missing halo weakens the overall pull that kept them on tight orbits. Spiral arms could unwind, halo stars would puff out, and some dwarf galaxies currently bound to the Milky Way might escape into intergalactic space. Over a few 100 million to a billion years, the shapes of galaxies would change. Disks could thicken, rotation speeds drop, and chaotic motion would replace smooth orbits. In galaxy clusters, the effect is more dramatic. Clusters are heavy with dark matter, so without it, many galaxies would slowly drift apart, and the hot X-ray gas would disperse. Gravitational lensing, the weird bending of light by mass that lets us map invisible matter, would fade. Distant images wouldn't be warped the same way. On the largest scales, the cosmic web of filaments and voids would lose its main adhesive. Slowly, the architecture of the universe would soften and smooth out. Now a twist. Much of the universe we see today would never have formed if dark matter had been absent from the start. Stars, galaxies, and clusters rely on that early gravitational clumping. So asking what happens if it disappears now is different from imagining a universe where it never existed. In the latter case, structure formation would be severely suppressed. Another subtle point. Dark energy still governs cosmic expansion. So the universe's accelerated growth doesn't reverse just because dark matter vanishes. And because dark matter interacts so weakly, removing it wouldn't trigger a shower of particles or radiation. The change is in gravity's bookkeeping, not in explosive energy release. For civilizations in distant galaxies, the sky would slowly grow dimmer in a different way. Fewer mergers, altered star formation, new galactic neighborhoods drifting apart. For us in the Milky Way, the Sun's lifetime and Earth's orbit remain essentially unchanged for billions of years. Life wouldn't instantly be threatened by orbital dynamics. The emotional takeaway is strange. The universe would be a quieter, lonelier place, a slow unweaving of the cosmic tapestry that once held galaxies close. The scientific payoff would be huge. Losing dark matter would break a lot of cosmological predictions and force us to rewrite cosmology from the ground up. It would be a detective's nightmare and dream combined. We'd finally learn what dark matter really does by watching the universe reconfigure itself. So the disappearance would be profound in the slow, geological sense of the cosmos, not a sudden apocalypse, but an unfolding transformation across eons. That paradox, invisible, everywhere, and responsible for both cosmic creation and quiet cosmic decay, if removed, is what makes dark matter one of the most haunting mysteries in science. If you like this thought experiment, hit like, subscribe, and tell me in the comments which cosmic what if you want next, and I'll dive in.